Okay, nice to see old friends and new faces. I'm Wei Cheng Huang from HPC Taiwan, so I'm going to do the update this year. Not much excitement, but we have a new adventure in this. Okay, so the role, I'm from HPC Taiwan, the only supercomputing center in Taiwan, supporting academia and industry, partner and government. So our role has been a little bit changed. In addition to the supercomputing and network, we also are redirected into the big data arena by the government. So there are something I would like to share to you. Like in this the service architecture, usually we have core facility and all the way out. And here you can notice that we have dedicated ourselves to the big data analysis clusters in the past year. So this is the historical mind of our supercomputing development. Now currently we extend our hands to the big data area. So this is, but again, in the conventional supercomputing, we still work on that. But unfortunately, we don't have new machine this year. But the other agency, which is CWB, they have a new machine this year, supposedly, and it's still under construction, but it's going to be delivered this year. So this is the current facility capability of NCHC, totally 300 teraflops. And largest one still the Alpus, which was built in 2011 and kind of aged. So we are in the process of acquire the budget from the government. We failed last year, and we are trying again this year. And hopefully it will be delivered in 2 years. And this is the utilization of computing facility. There are 2 points I would like to point out is, well, first thing, you look at the distribution of computing power, that's normal, that's regular. But this year we have industrial application engaged. Now this is very important company in Taiwan. Usually we want to engage with the industry, but we always fail because of their secrecy. But this year, we do have that company and coming to run on our system after a hassle of lots of security enhancement. And also, since the demand is keep increasing, but our facility is not increased, so some of the demands are routed to a cloud provider like Amazon. So this is what the status now in HPC. And of course, in storage, we have 6.5 petabytes of capability here. And it's distributed across 3 sites, so it's kind of guaranteed the data won't be lost. And this is the network backbone and also the international connection. Not much difference except at the Q4 of this year, the backbone within Taiwan will be 100 gig per second backbone, that's for sure. Legal problem has been resolved last month, so that will be there. Okay, talking about a CWB machine, this is for weather simulation, weather forecasting. So it's dedicated for their daily work, daily routine. The machine has been, the project is like it's $50 million US project, and it's going to be delivered this year. Okay, and total capacity will exceed 100 teraflop for the RMX, and only for the weather simulation only. And probably you won't see it on the top 500 because it's a dedicated government agency machine, and they don't like to show it on the popular area. So we went through a lot of trouble to get this information. And this is Fujitsu machine. It's same as the K computer, but with upgraded version of it. Now the other thing is the big data of NCHC positioning. This is whole chart of the government big data. What they want to do is, for all the government agencies, they collect all kind of data, and they want to analyze it. The main point is, if you can across the database, you can find something new. Now this is where NCHC is sitting. All the data will be forwarded to NCHC, and the researcher can do the analyze on that one. So in order to fulfill the requirement, we are building like specifically for the big data analysis. First, we are going to have a data hub which will collect all the information from government agency. Then we have a big data analysis environment. The reason for a separate hardware architecture is because the application characteristics totally different from HPC. And so this is the whole status of the build-up. I'm not going to go into detail of it, but basically it's running Hadoop underneath. And this is the architecture of it. Currently, we are running like a 40 gig to connect all these nodes together. Various businesses kind of a little bit different things about the storage. We are not going to adopt the solution with metadata server, which will create a bottleneck. So we can use the ring type of solution. So it's going to have a hash table to compute which data will go to which node. Okay, this is the rough picture of that. So this is the system build up. This year we are going to have 300 nodes, and next year we'll expand it to 400 nodes. And the dedicated storage space for this is 1 petabyte and 1.5 petabyte and keep going. And on the system, we're running HDFS2 and with Yarn, with container mechanism to provide different services to different kind of applications. So this is for your reference. And one thing we are facing is the DID thing. If we have all those government data collected together, you are worrying about legal privacy. So we are working on this. How can you DID the data? In the meantime, you can merge two databases together without those IDs. This is something currently working on, and we are going to deliver it next month. So for the big data application, inside the NCHC, we have environmental sensor network to collect all the data. And also, we have several sister institutes which involve with aerospace, climate simulation, ocean observation, and all those data are actually collected into the ESOD and stored in SSC for later use. And this is one application we are working with, the healthcare data, and we provided like a VM service to different research centers under their demand. So the data, again, forward to our center, but user can log in from remote site under severe civilian camera around them to make sure they don't copy the data out of it. Okay, and other applications like data analysis for achievement of graduate students and also physical data for students, all those things are going on. I'm not going to go into the detail of it. And for the government data, there are several areas identified, like finance, like food traceability. All those kind of things are actually involved in this. And also for the scientific data, like climate and weather, like network net flow, like post-storm sources and energy physics, all these kind of things will be involved in this data processing. And also for the civilian data, like a social network, customer behavior, all those multimedia, all those things, and also including this national big data project. And this is something, basically what it's saying is with open data and the big data technology and with the service provided by cloud, hopefully we can create foreseeable value out of it. So this is, okay, and talking about conventional HPC, this is the new machine. Actually, you can see it has been postponed for 2 years. And now we expect to have kickoff in next year. And anticipated production run will be 2017. Actually, today is 15th, right? The first round of review of this proposal is going on right now in our hometown. So we shouldn't be here instead of we are here. And, well, stay out of fire. And so, but paradigm is we are going to move our computing to the data. This is concept we are going to adopt. So the purpose of it is, some of the day we hope that the big data and also the HPC hardware can be merged together as one single piece of facility instead of a different set of computer. And this is the demands from the major application on this petaflop machine. Okay, and this is our whole view about the future data-centric framework for our HPC as well as big data analysis. So just quick. So our thing is we are not going to talk too much about HPC, but HEC, high-end computing, which include HPC. So again, still HPC capability build-up is continuing effort, and we hope, as I just mentioned, we hope to have a unified facility in years to come. And also, we are last month we are signed to look into the Industry 4.0, which will involve IoT and collect all this big data issue all together. So I thank you. Question.